Welcome, my friends. Welcome. Just a minor thing for you to know as we kind of get started on our journey here for this last week of review is, remember, we're not going to be able to get every question correct. I'm just going to go through the ones that I think you're most likely to get right, considering the work that we've done in class. So for some of these that you're not 100% sure about, it's okay. Remember, just go through and do the ones you know absolutely what to do. So we're going to go ahead and get started right away. We'll try to keep each video under 15 minutes, right? You only get 15 minutes per question. So let's try to see if we can kind of emulate that process. So as we kind of read through here, Johanna jogs along a straight path from 0 to 40. Johanna's velocity is given by a differential function v. Select the values of v of t, where t is measured in minutes, and v of t, let me just make sure I'm in a different color. V of t is measured in meters per minute. So if you think about where we're at right now, just in general, right, we're in velocity, right? They're giving us velocity. All right, and so from that point, we're pretty much we're either going to do work in velocity, we got to get to position, or we got to get to acceleration, and that's the only directions we can go in this scenario. So use the data in the table to estimate the value of f prime of 16. What we're just doing, basically what we are doing is taking the derivative to get acceleration, but we're not given an equation, right? We're given a table values, and the best way for us to estimate that is rise over run. So 16 falls somewhere between here. So let's label this x1, y1, oops, there we go, x2, y2, and let's go ahead and write it down. 240 minus 200 divided by 20 minus 12. Being able to just kind of try to work this. Remember, this is non-calculator active. 40 divided by 20 minus 12 is going to give us 8 here. There we go. 40 divided by 8, right? We could do some work, and that's going to give us 5. So the approximate acceleration is 5. Well, remember, this is rise over run, and the rise came from this table, which is meters per minute. Meters per minute. And we are dividing by delta x, or this case delta t, which is minutes. So 5 meters per minute. Now in this problem, it did not ask for units, right? Since we are not being asked for units, we don't have to put this here, but I recommend us doing it just for now so that you get practice more with units. All right, so with that being said, that kind of completes that problem there. Let's go ahead and work through on the rest of these. So let's go to, here we go, part B. So I just put the table and everything. Using correct units, explain the meaning of the definite integral in the context of this problem. Approximate the value of that definite integral using a right Riemann sum with the 4 intervals indicated by the table. Well, if it's helpful, you can always do the Riemann sum approximation if you feel more confident with that, and then you can worry about explaining this later, right? I think for me, I'll just go ahead and get writing. So I'll write 0 to 40, absolute value of v of t dt means. Now if you think about this, let me put the absolute value, there it is. Remember, we're in PVA. If we take the antiderivative of velocity, we're going to get position. Now when we put absolute values, well, we're going to get position, but in this case, let's think about it. Our units is meters per minute. We're going to get meters if we go to position. So we're getting the distance, right? The distance Johanna traveled. Now, because it's the absolute values, all of these here are going to be positive. So what is that telling us? Well, it's going to tell us the total distance Johanna jogged along the straight path. So that's what the absolute values are telling us. And again, antiderivative of velocity is position. In this case, is our distance. So let's say this means the total distance, that takes care of the absolute values. Total distance Johanna jogged in miles, right? Being very careful because it's saying using correct units. So this means the total distance Johanna jogged in miles from t equals 0 to t equals 40, and we're in minutes. There it is. Boom. Right? Notice how we explain this part of the integral, which is the total distance Johanna jogged in miles. And then the last things to explain is our bounds, right? And that's where we have it right here, from t equals 0 to t equals 40 minutes. Boom. So that completes that first subset, that question right there. Now let's go ahead and use a right-Riemann sum with the four basically these four rectangles that we're going to get, right? So let's go ahead and do a right-Riemann sum for that. Now you can pause this video. You can go ahead if you want to draw it. Some of you kind of have a shortcut. You guys are able to, you know, go through and be able to do this rather quickly without that extra support. But nonetheless, I like to just go ahead for now, especially for those of you that find this a little confusing. I like to go ahead and write it out. So 0, let me just write 12, 20, 24, and 40. Boom. Okay, one thing I really like to do as we talk about is just analyze the y values: 0, 200, 240, negative 220, and 150, right? So I know 240 is the max value, then 200, 150, and last but not least, we have something at negative 220. There it is. And we're not missing anything, right? And we have 0, the 0 mark in there. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, bam. Now it's just a matter of plotting our points. So let's just go ahead and do that. 0, 0, 12, 200, 20, which is 240, 24, which is negative 220, and 40, which is 150 right there. Here we go. And we are using what kind of Riemann sum? Well, a right Riemann sum. So we're going to start from the right. So we're going to get a Riemann sum here, starting from the right. There we go. Boom. And I like to just go ahead, and as we're kind of writing this through, I like to go ahead and begin to think about what my length and my width is going to be. So you know your width here is 16. The top portion is 150. Now let's go to 20 to 24. Again, start from the right, and we got to make a rectangle. So you're going to get a rectangle here. Okay, this width is 4, and we know this is 220, right? Now let's go ahead and go to the next right point, and let's go ahead and draw our right Riemann sum. Okay, which is here. All right, from 20 to 12, we all know that to be 8. So let's go ahead and mark this as 8. This is 240. And then last but not least, right, we got this right here, which is 12 and 200, right? So again, that's kind of the long way if you wanted to sketch it, but you know, it's and you feel like you're confused. This is the points you want to get right. Do it correctly. Remember, you could always use the tables like we talked about and just do a right Riemann sum that way, and then proceed on through, right? And you're using the right outermost point. But anyways, some of you can do that pretty efficiently. For others, this is maybe the best way of going about it, right? So we have this right here, we got this right here, this right here, and this right here. So let's go ahead and begin. I guess I'll just do it right over here. We're gonna get the integral from 0 to 40. The absolute value of v of t dt is approximately equal to, very important that we put this out. And now let's go ahead and begin to do this. We're going to get 200 times 12 plus, right, this is just this first rectangle here. And again, you can start from the right if you want to. It doesn't really matter. We just need all 4 now. We did a right Riemann sum. And once I have my picture, I'm just getting my rectangles. This is the height of this rectangle is 240 times 8 plus, well, this is where you have to be careful because we're doing the absolute values, which means that this rectangle down here is going to be positive from the absolute value. So we just have to know that this is 220 times 4, and then plus the last rectangle, which is 150 times 16, right? We kind of have that there, right? If you want to, because I know you guys are accustomed to this, we can put an extra set of parentheses there. And now it's a matter of us doing some mental math to kind of get this figured out, right? So 200 times 12, 240 times 8, and 220 times 4 plus 150 times 16. And we get 6,808 miles. Meters. Why am I saying meters? This should be meters, Wow, I'm really going crazy. Should be meters, right? The problem was in meters, not miles. Kind of a little AP trap there that I almost fell for. So just so you know, it should be meters, not miles, right? The problem is meters. So that's very important. Just a little minor mistake there. But just keep that in mind. All right, let's go ahead and continue on to part C. So that would be something to really keep in mind of part C. Bob is riding his bicycle along the same path. Bob's velocity is modeled by such and such, where t is measured in minutes and b of t is measured in minutes per minute. Find Bob's acceleration. Well, Bob, if we go over here, Bob is PVA. We are given his velocity and we want to find acceleration. That means derivative. So let's take the derivative, which is 3t squared minus 12t. Right, 300 is gone. Now let's just go ahead and plug in 5. 3 times 5 squared minus 12 times 5. And again, now this is just a matter of doing some mental math along the way. And we get 15, right? We get 15 here. Bam. 15 and meters per minute. Per minute, right? And you want to go ahead and write that out. Let me just double check something now. Boom, 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 boom. Good, good. So hopefully that makes sense. That's not too bad. Just finding his acceleration, derivative, plug in the 5, and here we go. Let's go to part D. Based on the model B from part C, find Bob's average velocity during the time interval 0 to 10. So we know if we want to find Bob's average velocity, right? Average velocity. There's two ways we could go about doing this, but the one way that I think is going to be the most efficient about doing this is using our antiderivative. So this is talking about Bob, which means we're going to have to utilize his equation, right? And luckily for us, they already gave us the equation for its velocity, which is 6t squared plus 300. Let me just write that down. Let me scroll up, double check. T to the third power minus 6t squared plus 300. Beautiful. We want to find his average velocity. Well, we know average, right? Whenever we want to do the average, we always divide by the intervals. Well, 1 over 10, because it's from 0 to 10. 10 minus 0 is 10. And we want to find the average velocity. We already have the velocity function. So this is from 0 to 10. T to the third minus 6t squared plus 300, which is the velocity function. Bam. Right? And this is going to give me my average velocity. And again, if you wanted to double check, right? How can we double check our work? Well, we got this right here. B of t is meters, right? Not making that mistake again, over minutes, multiplied by minutes. And we're dividing by minutes, right? So if you think about it, your minutes are going to cancel out and you're left back in velocity, and the antiderivative is pretty much adding all your velocity of all the velocities of the function, and then you're dividing by the time, which is going to give us our average velocity. So now that we have that there, now it's just a matter of going through and doing the work here. So let's take the antiderivative, t to the 4 minus 4, 6t to the third over 3 plus 300t, making sure you don't accidentally put an x right by that. And we're going to evaluate this from 0 to 10. Cool. And the nice thing about this problem is that we don't need to plug in 0, because 0 is going to cancel everything out. So it's just a matter of plugging in 10 to the 4th divided by 4 minus, this is 2, 10 to the third power, right? This simplifies down to be 2 plus 300 times 2. Okay, and if time permits, you can go ahead and just simplify that through and then get your final result there, right? And that'll give you your average velocity. But with that being said, I just kind of want to go ahead and go through the main work here. I think you should be able to get that practice and double check it with a calculator if you need to. But other than that, that'll conclude that first video for us here, which is just going over Joanne and her jogging and just kind of having to use a Riemann sum and kind of some approximation problems, right? Well, take it easy, my